Okay, Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is a video specifically for MECH 2118 Automotive Engineering Lab 1. This is for your submission of your video group presentation. As I have mentioned that one of the objective of this video presentation originally in the normal semester is that for you to present and then you can get direct feedback from the lecturer or from the evaluator when you present or after you present, right? So that you can improve and know where the gaps is, etc. that you need to take care of when you want to go to finish your report. However, with this fully online circumstances, so I think this is the way that I can do it. So I will cover the video presentation that you have submitted and give direct feedback here, right? So hopefully, inshallah, in terms of the format of this video, because it will be compiled for all the group presentation, right? So if you want to just go and dive into your own presentation and my comments, hopefully I will put the timeline, the timestamp, so that you can straightway go to your group number in the timeline there. But of course the video will be available for you to also to take note of what other comments for other groups presentation as well, right? Because normally in the normal presentation you can as well listen to other presentation and comments also if you need to or if you want to, right? The opportunity is there for you to learn from each other, inshallah, right? So first and foremost, I will go into the just to refresh what is the given instruction for the submission, so that when I do the comments it's based on that, inshallah, right? So I look at this iTalim instruction, so let me click here. Alright, so this was the given instruction to all of you, right? Before you have done submitting the group presentation video due 21 or 21st December, and next week you should already, or you should submit the report, right? And hence this feedback is to help for that report. Okay, so the objective is to, number one, to discuss the achievement of the objectives of the experiments from analysis of data obtained from the internet search, right? So we have gone through this. In terms of this semester, it is different in the sense that you will not have the opportunity to do the physical experiment in the lab, so we have to modify what we can do, and hence for the semester you have to gather information from the internet and then do some analysis on what is available there, and discuss how it what conclusion you reach, and how it help or contribute towards the achievement of the objectives. And number two, present the analysis that the group managed to do and obtain, okay, there's grammar there, obtain feedback on gaps still existing. So this video is also part of the process to give the feedback, inshallah, right? And then in terms of the flow of the video, what is expected, first to reiterate the objective, and then second just highlight why certain procedure is needed to achieve the objectives, yeah, and then briefly cite the sources found and used, and then what is the outcome of the analysis and how it leads towards the conclusion, right? So that's what the flow, the main items that you have to deliver. And then in terms of the format, the video recording of 4-minute maximum, right? So that's I understand that it's very short period of time. You have to find way to compress all of those, just highlight the important information and still deliver what is needed to be delivered. and then no need to verbally introduce the team member, just display the important information for 5 seconds, because I do not want this introduction of the members take a significant amount of the video, right? So just 5 seconds of that introduction so that I can refer to and then move on to the main content. Alright, so that's the just to refresh the instruction that was given. So as long as you comply to the instruction, inshallah, your submission will be good. Right, so the way I will be doing this is, because you have 2 experiments that you do, so I think I will be doing one experiment after another, so that I can follow all of the presentation with regard to one experiment before going to another, right? So meaning that you have 2 portions of this video that you may want to go to for your group, if you just want to watch for your particular group. Alright, so here, so I will be doing in sequence, group number 1 until group number 9. Hopefully this video will not be that long, and for experiment, the first experiment, and then go to the second experiment. Alright, so here goes. So this is for group number 1. Okay, this is, they give a link to the video. So we will go first for heat treatment comparison, where basically we do multiple heat treatment and then we compare the results, and then we do analysis and make conclusion. Right, so here we go. So go to this one.
Warahmatullahi wabarakatuh. In this video, we will run a data analysis on the effect of different heat treatment experiment.
Wait a minute, before we go, first comment, looking at the time here is 4:34, so it's 34 seconds more than 4 minutes, so that's the first thing. And then of course you have group information. Alright,
The objective of this experiment is to study the effect of different heat treatment on the mechanical properties like tensile strength, hardness, yield strength, and Young modulus. The second objective is to study the effect of different heat treatment on the microstructure. To achieve all the objectives, we use an
so you say in terms of properties and microstructure. Okay.
ST372 steel as the material of the specimen in this experiment. Then on each specimen, we run 4 different heat treatment, which is annealing, normalizing, hardening, and tempering. Then to measure the mechanical properties on each specimen, we run Brinell hard test on every specimen. In this video, we take the
Okay, so one comment is, because what was, I think this is already going to the data, right? So in terms of what was requested in terms of the procedure, it's not just because the what I mentioned is what is it? Why certain procedure is needed in terms of doing the analysis and getting the conclusion, right? So you have to present the why. Why do you do that, right? Why do you for example, we have multiple specimen. Why? Because we want to compare between them, etc. Right? So if we have multiple heat treatment, why this and that, right? So those what is expected to be highlighted, right? Because if there is no reason to repeat several different process, then we would not be doing that, right? So those are missing, I think, because you just said some of the procedure, but not the reason, right? What was specifically mentioned is why the procedure is needed, right? So that's one note.
data from the report of effect of heat treatment on mechanical properties and microstructure by D.A. Fadare, T.G. Fadara, and Y. Akanbi from Department of Mechanical Engineering of University of Ibadan, Nigeria.
Wait, so you are taking only from one source? Okay, that's one comment. From what you presented, it's just one source. So my question is, do you only have one source? Because in the previous submission, each person have to submit at least two source, right? Meaning that in a group it can be, because you have 3 or 4 members, you can have like up to 6, perhaps 8 different sources that you have found. So why only one is used? Okay, you have to justify that, especially if you are doing exactly the same thing in your report, right? What happened to the other sources? Is it not valid? Not, I don't know. There's a comment there.
Changes in mechanical properties. First, we look at the annealing process. Annealing process will be increasing the ductility, and also the internal stress are relieved, but the hardness of the material will decrease. The main reason for the hardness decrease is the slow cooling rate. The slow cooling rate causes the carbon content in the material gets enough time to react with oxygen and thereby decreasing the carbon content. Next is hardening process. As the name suggests, the material hardness will increase. This is because of the quick cooling rate, making the carbon content doesn't get enough time to react to the oxygen and trap in the material. There is also a noteworthy increase in tensile strength and decrease in the toughness. Third is normalizing process. The normalizing process doesn't show much changes, only slight decrease in toughness and increase in hardness. Whereas the tempering process also has a slight increase in the toughness and also the hardness by a small margin.
Now moving to the
Okay, so okay. Now, one comment, because if I remember correctly, in the procedure part, you just highlight different specimen and then Brinell hardness test, right? If I remember correctly, and suddenly in your results, you should result for 3 different type of test: tensile, hardness, and also toughness. So this mismatch here, so you have to explain that, and so everything have to be, I do understand that you have to gather information from internet, available information done by someone else. Fine, you have found some of this, but it have to uh, be consistent throughout, right? So if you have all these 3 and you want to present these 3 properties as the results and the analysis part, the procedure should tally, right? Meaning that you cannot get all of this just from that one hardness test. It doesn't make sense. So that is another comment. Second, um, the way you present, I'm not sure how the source present itself. Is it a theoretical, meaning when you say what is the effect of each of this process, or it is a conclusion based on result? Because if we are doing the lab, the data should lead and point towards the conclusion, right? So how do you get this, meaning how do you suddenly see annealing results in this, based on what, right? So what is the analysis done? You compare tensile, you compare toughness, you compare hardness, and which, meaning when you say increase in ductility, from where, from which graph you getting that conclusion, for example, right? Of course, some of the words are directly straightforward when you say increased toughness and then you go to the toughness plot. But how do you get that? What is the analysis when you say increase? What do you mean when you compare what to what, right? So that's where you have to the reason, you have to have a reasoning in the procedure when we say what is the, why certain procedure is necessary. you compare untreated with treated and see how it goes, for example. Right, so in terms of the analysis done, okay, you have some others about the microstructure, right? But from what I understand, what was just presented here is straight away to the conclusion, meaning it's not clear how you get that from the data. Hopefully you understand my comment. All right.
Now moving to the effect on the microstructure. The microstructure on the untreated steel has two main constituents, that is ferrite and pearlite. As you can see in the figure, the light color region is ferrite whereas the dark color region is pearlite. When the specimen is subject to an annealing process, the ferrite grains undergo complete recrystallization. Due to the slow cooling in annealing, austenite is transformed to soft pearlite and also means to eat ferrite, or cementite, which increases the brittleness of the steel. Then the normalized sample showed that there were too many short graphite flakes surrounded with patches of uniformly distributed pearlite range. In normalizing process, the cooling rate is fast. Therefore, ferrite and cementites are formed in very less quantity, thereby their brittleness degree decreases. In hardening process, the faster cooling rates allows martensites to form directly from the austenites. And due to the rapid cooling, the microstructure formed is hard, which results in an increase in the tensile strength and hardness. In the microstructure of tempered specimens, highly recrystallized ferrite grains with some secondary graphite site was observed. Also, the micrograph shows that the microstructure of tempered samples consists of number of carbon particles precipitate out from the matrix.
Conclusion.
Okay, so that's another thing. Of course, I do understand 4 minutes is very tough to compress everything in. For the microstructure as well, what you cite or what you highlight, I think is straight with taking the conclusion of your source. Yeah, so because what we are trying to do is to emulate the process that they have done as well, right? We should be doing that in the lab and then come with the conclusion, which should tally with their conclusion, right? uh, but in this process you shouldn't just take their conclusion, because that will be a totally different process if you want to do that, right? Here we are trying to emulate. Of course you can use what is already there, in the sense that they have the data, they present the data, and then they formulate the conclusion, right? Analysis on the data to formulate the conclusion. You can use that if you want, right? But it has to be presented in that flow for this task, right? um, okay, conclusion.
Tensile strengths yield strength and hardness of medium carbon and ST37-2 still increase with plastic deformation, while ductility and impact strength decrease due to strain hardening effect. Hardening is strongly recommended when the strength and hardness are the prime desired properties in design. The results obtained confirm that improvement in the mechanical properties that can be obtained by subjecting this material to different heat treatments investigated in this study.
Assalamualaikum warahmatullahi
Okay,
wabarakatuh.
so the conclusion that you have should tie it back to your own objectives. So when you say, because I assume this is from their conclusion, when you say specific about carbon and ST372, is this part of your objective? Because I can assume their objective involve this, right? What happened to this carbon and ST372 steel? But I don't think that you have this in your objective, right? So it doesn't tally there, so it becomes meaning I cannot relate, right? And then the result confirm the improvement in mechanical that can be achieved. So is that also your objective, right? To confirm the improvement can be obtained, right? So those things have to meet, right? So because your objective is based on your conclusion should be based on your objective, right? So when we take data from others, they have their own objective, we have our objective, right? So we can use and see what their data are saying for our own objective, right? We shouldn't be confined based on their own objective, right? Because data is data. Perhaps they do in a certain way to meet their own objective, but their data based on that procedure can also be used for our objective, especially also if you compare to other studies. Right, so those are my comments, because in terms of conclusion formulation, okay, in terms of conclusion formulation, it's not clear. Because throughout the discussion or analysis, I do not realize where this carbon NST-37.2 still is ever mentioned. Because if the conclusion is focusing on that, it should be highlighted before, right? Or is this just the material that they use? But you should specify that, right? Okay. So those are my comments. So in terms of the, I think throughout my comments, I think you can gather the gaps or the improvement that is needed for your report. So please take note all of the comments and make sure the narrative is clear, in the sense that when you want to do the report, it should feel like it's your own analysis, not just you just pick up analysis from somewhere and then just shove it in to become your report, right? So if you do that, the marking will be quite unforgiving in that sense. All right, so I guess, and as well in the report, maybe you are affected by the limit of 4 minutes that I give, right? But for the report, I do expect analysis that involve more than one source. Yep. Alright, so that was my comment for this group number 1 submission. So we will be moving on, inshallah. Okay, this is submission by group number 2. They have submitted on this. Okay, so this is group number 2. They managed to squeeze just below 4 minutes. Okay, let's see what about the content.
Assalamualaikum warahmatullahi wabarakatuh. So this is my group's video assignment for heat treatment.
Wait a minute, you have a background music for this submission?
Of the materials after heat treatment.
To study the outcome of different cooling rates. Interesting. Okay, you state the objective, but okay, let me take note of your objective. Okay, different outcome of different cooling rate, and reheating on microstructure and properties to observe hardness, tensile, percentage reduction, and percentage elongation after heat treatment. Okay.
So this is the materials that we want, the properties that we want to observe after the heat treatment has been You must read.
Okay, maybe in terms of just a short comment, is that a correct reasoning? Um, heat loss, does it affect quenching? Meaning that
The heat one of the quench spends let the specimen cool off in the furnace up to 70 minutes.
Okay,
okay. So again, I'm not sure whether how I describe the instruction is not clear or something. We will see whether every group is like this. Um, when it is mentioned that you have to highlight why certain procedure becomes important in this analysis. The highlight is the why. Why do you need to do that process, right? From the first group just now, it's not mentioned here. Also, it's not mentioned because what mentioned is just the procedure being highlighted, not the reason. Yeah.
we continue the source that we use for the heat treatment. The source that we use from the analysis of mechanical properties of mild steel applying various heat treatment is by Mr. Nazma Sultana, Muhammad Firdaus Hassan, and Mehdi Islam. They are from the Department of Industrial Engineering and Management, Khulna University of Engineering and Technology from Khulna, Bangladesh.
Okay, again, so I assume only one source that is being used for this video presentation. I would expect multiple sources for your report, which is why initially each group member have to find at least two, and for the 3 or 4 members you should have multiple sources, and the analysis have to consider those multiple sources, right? Especially for the report. I do expect for for the presentation as well, but perhaps I'm not sure what is the reason the group limit to only one source so far. Is it hard to compress into 4 minutes? Is it what? So, but if no justification is given, normally is assumed as a non-compliance, right? Because no justification is given.
For this experiment analysis based on the source
Okay. What is the conclusion? I'm not sure, not clear. Uh, you have several because for this group the because they show the table for the mechanical properties that include calculated numbers, right? For example, Young modulus, percentage reduction or whatever that is, percentage elongation, right? So those are not raw data. Those are calculated data. Again, perhaps due to the limited time, because it's not clear that is from what test, and how it is derived, right? So those things I'm missing. And what is to be concluded by the microstructure? And I'm not sure, because going back to the objectives, there's mention about different cooling rate, but throughout this there's no, because you have, if you specify those things in the objective, you have to go back and which one is the what different cooling rate, you know, because the way it is, because this table, if you see, or the label given for the microstructure here is just different type of heat treatment, right? You can see that, okay, this different heat treatment essentially have different cooling rate, where quenching is very quick or very fast cooling rate. But when you specify the objective in terms of cooling rate, you have to go towards the conclusion to relate to the cooling rate as well, right? So untreated, annealed, normalized, is this in the flow from slowest cooling rate to the highest cooling rate or something in terms of the plot here, right? Because it's just labeled annealed, normalized, hardened, right? I cannot relate with cooling rate, for example, and I'm using cooling rate because you yourself specify that is the objective, right? So there's a mismatch there. Okay, so those are the things, and of course here it ends just like this. Of course I didn't mention that I need, for the format of the video submission, I need specifically what is the conclusion, but what I want to see is how the flow towards the conclusion, right? So that is also missing, because the conclusion mentions specific things. I think it's missing in terms of the analysis going back to the objectives. Right, so those are my comments. Again, as well, only one sources is being considered. What about the rest? Make sure you elaborate on that in the report. Okay, so that was group number 2. We go to group number 3. Alright, so
Assalamualaikum warahmatullahi wabarakatuh. In the experiment of the effect of different heat treatment, we have three
okay, so they have, okay, in terms of this one, it's 10 second more than 4 minutes, and then they have the group info at the beginning.
objectives. First, to analyze the effect of different heat treatment in terms of hardness and toughness. Second, to measure the impact of strength and hardness of the materials after heat treatments. And the last one is to study the advantages on the material after undergoing heat treatments.
Okay, so in terms of your objective, you do specify to analyze different heat treatment. Okay, measure the impact, strength, to measure. Okay, that's like the procedure, or to the steps to get to the objective. And to study advantages, so you specify study advantages. Now whenever you specify anything as your objective, don't feel surprised that those are going to be asked directly, to be provided in the conclusion or the analysis, right? In terms of the advantages, study the advantages.
So, there are some procedure that we need to do to determine the hardness and the toughness of the specimens. To determine the
By the way, this is more on the presentation style or approach, right? Is there any reason why the background, the color, the text, is there any reason of this? Is it helpful, the arrangement and etc.?
hardness, we have to undergo the process of Rockwell hardness test by using the Rockwell hardness test device, and then we record the data in the table. To differentiate the toughness of each specimen, we begin the therapy test by using the pendulum test machine, and then we plot the data. All the data from the test were recorded to proceed on an analysis of the materials undergoing heat treatments and analyze the effect of heat treatment for steel and aluminum specimens. So,
Okay. Now, the attempt to relate to why, because in the first group I mentioned that is missing. Here the attempt is there, right? Why the procedure is important, but I just comment on the what is mentioned, right? In order to determine hardness, of course, we use Rockwell hardness test. Okay, understood. Okay, but that is okay. If you say the objective, because you mentioned something like, if the objective is to measure the hardness, then that's why I use Rockwell hardness test device, because I want to measure. So it does answer that question, I guess, but because actually that goes to the objective in the first place, right? Because in the objective you did start how to see the effect of different heat treatment. So where does it translate here, right? So that's the missing part, for example, right? I hope you understand. Yeah, so when we say procedure in the sense of relating back to the objective, when you say the objective is to see the effect of different things, that's why in the procedure you have those different things. For example, uh, and that's so those reasoning is what is missing from most of this. But the second one mentioned here, in order to differentiate the toughness of each specimen, we begin the Chappie test by using the pendulum machine, and then we plot. What? Okay, I'm not sure whether you have the right idea to convey, but the sentence is off or missing something. Because if you say, in order to differentiate the toughness of each specimen, meaning want to see the difference, we begin the Chappie test by using the pendulum test machine. I'm not sure whether that's the sentence is not structured correctly, because when we say we begin the test by using the pendulum, I'm not sure what you mean by Chappie test, because the Chappie test itself is that test itself, right? So if you begin that test, unless you say you begin the methodology or you begin the procedure by doing the Chappie test and then plot the result according to the different heat treatment, right? If you mean that, then it makes sense. But the way it is written here, you begin the Chappie test itself by using the pendulum. Maybe you should go back and identify what is the meaning of Chappie test. Maybe I assume you misunderstand that, because the Chappie test is in fact referring to the test by using the pendulum machine, right? So it's not the whole procedure, because when we say you do the heat treatment, that's not the Chappie test, that's a heat treatment, the specimen preparation, right? And then you plot the data, that's after that. So the Chappie test is just the test itself. So you have to restructure this. I'm trying to best assume here that you want to say that we first use the Chappie test to do the impact test to get the value, and then we compare, by plotting we compare the values for different heat treatment, hence we can differentiate. If that is the idea, then yeah, it makes sense. And then all the data from the test were recorded to proceed on the analysis. You just want to say that all the data is recorded. Okay, I'm not sure what you are trying to say by the third statement here. Okay, so hopefully you get the idea of where I think you are missing, in the sense that in terms of the attempt, that is good I'm not sure. It's a decent attempt, I guess. In terms of highlighting the why to the procedure, right? But there's something here that need to be go back to your objective. What you see in the objective, especially in your case, this group number 3, I think. The objective actually said about advantages, right? So what kind of procedure you want to do, unless you want to revise that, right? So hopefully each group rethink what they specify as their objective.
Analyze the effect of heat treatment for steel and aluminum specimens. So, this is the sources that we have collected with the total of 8 sources. We compare the data and we finalize it.
So in terms of the stating the source, this is the first group that state multiple source, but I'm wondering whether the analysis will consider all.
Among of all the sources that we have find, we choose these 2 tables to be as a reference in this experiment. Data of this
Okay, why? Is there any reason there? You say from many, you just select this table. Okay, maybe it's for the short video, you don't have the time to explain, but in the report it has to be explained. You cannot suddenly just disregard. You see, mentioning I have referred to multiple source, but the other source we just put it aside. We just go with this one, right? You have to show all the results, the relevant data, and then if you want to filter and just focus on something for the analysis based on what criteria, you have to specify that. You cannot say simply making a claim of many sources and then suddenly just what we can see is just 1 or 2 sources.
experiment is collected from numerous sources. For the Sharpe test, the table of impact duration and percentage of increment on impact duration were shown. From the data above, we can see.
Okay, is this the statement, the way that you do when you do a report? Because when okay, from the data above, where is the above? Hopefully you understand my comment here, right? Because when you want to present, it should be in the form of the presentation, right? So when you say from the data above, what, where, right? So
see that the impact duration for aluminium occurs between 1.1 millisecond to 1.5 millisecond and 0.38 millisecond to 0.60 millisecond for carbon steel. However, both materials have the highest impact duration in the thicker specimen. This Sharpe test shown that the impact duration increases with the thickness of the specimen. It increased about 24% for aluminium and only 12% for carbon steel. Regarding this result for both specimens, we can conclude that the aluminium has a higher average impact duration compared to carbon steel. It is because aluminium is more ductile than steel, thus it has more elastic and plastic region in a stress strain curve before fracture.
now, interesting things here. Yet again, your the whole storyline, the whole how to say, from the objective to the analysis to the conclusion should be consistent. So when suddenly you have different impact duration, and then you have different thickness, when there's no mention of those things in the objectives or in the procedure, because if to make this consistent in the procedure, they should already state that okay, we vary the thickness of the specimen because we want to see the effect of the specimen, the thickness, for example. Then this makes sense. When there's no such thing as those things mentioned before, this doesn't make sense, right? Suddenly you measure the impact duration. You actually do that, meaning that I'm not saying that's wrong, but I'm saying that from the narrative that comes beforehand, you will not get this one, right? If you do not have what kind of sensor or something to measure the impact duration, suddenly you say, oh, we get 1.1 millisecond. You cannot from your eyes observe that, right? So yeah, please make sure you understand what, because all of these studies have their own objectives, have their own procedure, right? And you cannot just pick up those results that is obtained by that procedure and plug in to the procedure that is different that you stated, and then says this is the kind of the result that you can get. It doesn't make sense. Right, so make sure you kind of understand what's going on here. Hopefully this is not too difficult, because all those about impact duration, about thickness, even second level student can understand those things. Should be, right?
as more elastic.
The data that we get after doing the Rockwell hardness test. The table contains of the data get after doing the Rockwell hardness test.
So you have, okay, I believe the table above is taking the average, and then for different heat treatment, and on the bottom here is different hardness from quenching, medium, all are quenching. But what are these RE, whatever this is? You have to explain if you show it, right? Anyway,
The table contains of the data consists of sample and the mean value of the result for the Rockwell hardness test. In order to get the accurate value, we repeat the same step 3 times and take the average values. From the first table, hardening has the highest hardness compared to normalizing, annealing, and with the mean value of HRB of 112 HRB. This means that the material that is cooled by hardening, which is cooled by put the specimens in the water, is better than full annealing method. This is because the faster cooler rate can cause a material to have slightly less ductility and slightly higher hardness value than if the material had been annealed. The second table we get is the table of doing hardening to the materials, where we dip those specimens in water, oil and air and record their hardness data. We can see that dipping in water makes the specimens more harder than dipping them in oil and air. The unit used to read the hardness is HV. Therefore, water, oil and air are 258, 191 and 174 respectively.
what does dipping in air means? Okay, so okay, several things. Of course, in terms of the presentation, you have to differentiate significantly how you say certain things in presentation and in report, right? So from the first table, I cannot see. What should I do? I should, meaning when you present something, if you want to highlight something, those things should be there in the same page, right? Because in report you can flip to, oh, wait, stable. But in your presentation you are not dictating, meaning that you the don't, meaning of course in the normal presentation you are, the audience is not in control on to reverse the slide, etc., right? What more in the video, you can say I can rewind the video, but that's not no longer the format of the video presentation. In terms of the analysis, right? What was the objective again? Okay, this is not yet over, but they said about to study different effect. Okay.
For the conclusion from the
Okay, so I can sense that this is the meaning what you can take from the report, that is your source. But again, my suggestion is to yourself analyzing the data. right? So maybe I'm expecting too much. Is it that you are able to just see the data and then draw your own conclusion that relates to your own objectives, right? It will tally, it will coincide with their own analysis depending on their own objectives. But when you are confined with their own wordings, etc., it's hard to relate, because the beginning of the story doesn't match the end of the story. What is the advantage?
191 and 100 that different heat treatment gives us different mechanical properties on a specimen in terms of hardness and toughness. We also can conclude that the materials which receive different heat treatments can have different advantages. We can see that different heat treatments give different effects to the materials, hence we can analyze which heat treatments that give more good effects or advantage to a certain material. Thank you.
Okay, the word advantage is being used several times here in the objective as well in the conclusion, but throughout, does it specify what kind of
Different
objective
advantages.
is?
Material include that dipping in water.
So what advantages are here? Because when you say suddenly in conclusion, disadvantage, there's that advantage, but in the analysis there's no, okay, this shows that this is the advantage that is produced, for example, right? Those kind of analysis and leading towards the conclusion, only then it's makes sense. Then you conclude, okay, so we can see that this produce this advantage, this produce different advantage, this doesn't have any advantage, whatever. But when your analysis doesn't even have the word advantage, how does that relate, right? Maybe if I would put the assumption, you have the idea, oh, when I say that the material is what is better, cause the material to have slightly less ductility. So it's not clear which one is the advantage. So less ductility is the advantage, or slightly higher hardness is the advantage. It's never defined, right? So maybe the way you understand advantage is also different. So I'm not sure. Maybe the items is there to be discussed, but it's not clear how it relates to certain things that is mentioned in the conclusion. And okay, going back to what is expected, right? The analysis done. So I'm not sure whether you have done any analysis that can be, because the result is shown.
Impact duration were shown.
Okay, so I'm lost in terms of the analysis. Actually, I'm trying to figure out how the data and analysis on the data leads to the conclusion, right? I can understand what you're highlighting is taken from other people's, right? But then I have to give the mark to them, if you understand what I mean. Because here, okay, you have 5mm and 10mm. What is this? Is that ever mentioned in your procedure, or why you have two different, what is this? Is it thickness? Right, so, and then in the conclusion, is there anything about the thickness? Okay, so basically not matching. Okay, so that's what I can sense, right? So it doesn't match in terms of the objective to the data, and then to the conclusion that is say something when there's no discussion about advantage here, while there's something about the thickness here, but that is not highlighted. Is it not highlighted? I don't think it's highlighted, right? Is there anything about different, because you have different heat treatment? What is the purpose of that thickness? Is it just to see consistency, etc.? Okay, so many questions. Hopefully you take note of all those questions, and in the report those gaps, because the more question that comes when you have your presentation, especially the question that indicates the audience is puzzled, that is an indication of more gaps need to be covered, right? More holes need to be covered. All right, so that's for group number 3. Okay, how long will this be? It's quite long. All right, we will continue on with group number 4. Right, next we are going to group number 4. Let me search for group number 4 submission. All right, this is group number 4. So they have submitted a YouTube video, so we'll go there. Wait a minute, but they also give a file. Is it different? All right, so first thing, that this video is 4 minutes 39 seconds, so it's 39 seconds more than 4 minutes. All right, so we'll move into the video. So they have the group info, group number 4. Okay.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, want to present the first experiment, which is heat treatment. For this experiment, our main objective is to investigate the effect of different heat treatment on the mechanical properties of the steels. On the other hand, we also want to measure the impact of strength and hardness for the heat treat specimens.
Okay, so this is the objective statement: to investigate the effect of different heat treatment on mechanical. Okay, to measure the impact of strength and hardness. I'm assuming there's a mistake there, because unless you mean something about impact of strength and hardness, what does that mean? Because strength is one thing, hardness is another thing in terms of the parameter. Impact, if you are talking about impact strength, right, meaning that the energy absorbed during impact test, if you are meaning that one, so it's not really impact of strength, etc. So please check your objectives, because when you state the objective incorrectly, it will affect significantly, because that's the first thing that will be evaluated, whether the objective is correct. Because if the objective is just nonsense, the whole thing is just meaningless, so to speak, right? So make sure you check that one. This is group number 4, right? The second stated there. What do you mean actually by that?
Okay, so for the procedure, we need to choose 5 specimens of mild steel and grind in all by hand grinder. So the second step is place the specimen on the surface of Rockwell hardness test and record. Why we need to use this? Because we want to investigate the effect different heat treatment on the mechanical properties of the steels. So the next step is place 4 specimens into the oven and heat for 30 minutes. So after 30 minutes, we need to immerse the specimen into the specific quenching medium. So the next step is immerse one of the specimen into the oil and the other one into the water. This is called quenching medium. So the next step is we need to put the other one specimen in room temperature, which is called normalizing. The next step is leave the remaining one into the oven and wait the temperature drop. So then take the specimen and cool in water, which is called annealing. The next step is take the left specimen that we did not put into the oven and test its hardness using the roughness. So take 5 reading different points.
Okay, what is roughness? So please make sure you verify what you want to put in. Otherwise you will be saying something that can be picked out as, you know, it diminish the whole integrity of the whole thing, if you know what I mean. The evaluator or the audience will say that you do not know what you're talking about really, because there's one mistake there that indicates such. So please verify do you mean by roughness. Is there such a thing?
So make sure to test all the other 4 specimens also. So the next step is calibrate the Charpy test machine beforehand. So place one specimen in the middle of the machine. So set the pendulum to highest height and release it downward. This is because we want to measure the impact of the strength and hardness of the mice steel for the heat treatment specimen. So the last step is we need to observe and record all the data and repeat step 8 for other 4 specimen.
Okay, several things. Again, just like what I've mentioned about when we relate about the procedure, as we mentioned in the beginning of the video, if you watch from there, the what is needed or what is specified as your task is to um, uh, re, re, one, reiterate the objective. Second, describe why certain procedure is necessary, right? So yeah, you did more than needed in the sense that you pull out put every or more detail of the procedure. However, when you say, for example, step number 4, immerse one specimen in oil and water for quenching, and then step number 5, put one on ambient for normalizing. Is that really step number 4 and then step number 5? Can it be the other way around? Right, because actually you just have different heat treatment done on different specimen. There's no specific arrangement that, okay, first we have to do quenching and then we have to do annealing, right? You can do any which way, it still work, right? So that's where you have to understand, oh, why we do these different things is because we want to test for different heat treatment. It's not like a sequence. So those kind of things you have to be able to articulate to make sure to show that you understand that is what is happening. If you put it as such as currently is, it is understood as a sequence, and you do not even mention why the sequence is like that. Hence back the question whether you understand why we do certain things. The only reasoning that was mentioned is early on step number 2, I think. Why you do Rockwell hardness test is because you want to test a different hardness or something. You mentioned some form of reasoning, but the rest there's no reasoning, and there's mistake there, and then it doesn't need to be that sequence. So in terms of the audience, my perception is I'm not really sure you understand why this should happen. Should it happen in any of these steps? Is it necessary? Is there any reason for it to be being necessary? So that's my comment. Please understand and reevaluate before you put in your written report to avoid, your mark will be severely affected. Right. So.
Moving on to the roughness test result analysis. As we can see, in
Okay, again, you keep using rockness. Is that a real thing? Rockness test. Let me Google. Maybe you find something. Let me Google. Rockness test, because you keep using rockness test. Make me wonder what that is. What is it? Yeah, you can, if you just Google, you can see this Rockwell hardness test. And if you say Rockwell hardness test, then understood. But when you say rockness, what is that? Is it the level of rock or what? I do not know. So there, from there, it already, the yeah, I don't think I need to say much because you understand what I'm trying to say in terms of evaluation or in terms of audience perception. Okay. you know anyway.
Quenching process, the metal in the water record higher percentage raise in the hardness compared to metal in the oil. This is because water have higher cooling rate than the oil. Because of this, water allow quick cooling for the metal to form the martensite as well as increase the metal strength. Next, the metal who undergo normalizing process, we noted that the hardness of the steel drop. Same with the metal who undergoes the annealing process. The hardness of the steel also drop, and we noted that the metal produced is soft and ductile. Also, we can see at the right table, there's the link of the source where we gain the data. Next is the Chappie test.
Okay. Okay, roughness is one thing, but that's the thing because you have the source. So I would doubt in the source they say it is as roughness test. Second, in the data here you show initial, final, and raise, but in your procedure you never mention about initial, final, and raise. What is that? Is that related to the procedure that you have said, or what? Right. So you have to make sense of this and make sure from the beginning until the end the flow makes sense. You cannot, meaning the procedure is one thing and then for the result it's totally not related to the procedure. That there will be a problem there, right? So even though this is a good attempt in terms of showing the data and what is the analysis that can be observed, can be done, and what is the observation in terms of you have the column there stating higher percentage in quenching water than oil. Okay, good. That is a good thing, right? But the data itself, I doubt when you go back to your procedure it will give this kind of data. So either you revise one or the other, make sure it correlates.
Result analysis. As a whole, we can see that among metals with heat treatment applied, metals who undergoes quenching process record the lowest energy absorbed. This shows that quenched metal is the toughest among the others. And on the other hand, metal with no heat treatment applied.
So what is this? So all of the heat treatment becomes brittle, is it?
Record the highest energy absorbed during the test other than it is break into two during the test. This shows that these metals hold the properties of ductile. We also came to realize that different heat treatment will produce different hardness and toughness of metal.
Okay, so what, just one question, what is that energy? Energy what? Is it energy gain, energy loss, energy what? Right, so just be clear on that.
In this experiment, we can conclude that Rockwell test illustrates the hardness of metal specimen when heat treatment is applied on it. By heat treating, a metal can be made harder, stronger, and more resistant to impact. However, it also can make a metal softer and more ductile. Then, chapter shows whether a metal can be classified as being either brittle or ductile. A brittle metal will absorb small amount of energy when impact test, and a tough ductile metal absorb a large amount of energy.
Okay, just verify what this means because your conclusion, it says Rockwell test illustrate the hardness of metal specimens when heat treatment is applied on it. What does that mean? Because this is your conclusion. Your conclusion is Rockwell test illustrate the hardness of metal specimens. when heat treatment is applied. Please revise that because I'm not sure what that means. What are you trying to say? Yeah, as the first sentence there, because it doesn't make any sense as of when I read it. I do not understand what I'm trying to say. Other than that, okay, I think you try to have a good conclusion in the sense of relating back to the objective. What was the objective again? So do verify your objective, because that the mistake in the objective affect everything. Other than that, one thing that should be clear after this is how you decide or define what will be considered as ductile and what will be considered as brittle, and what is considered as softer, what is it, and harder, stronger, more. Okay, wait. On the left side you have conclusion about harder, stronger and more resistant to impact. But impact is on the right side, right, for Chappie test. So make sure it is clear which conclusion comes from which analysis, because initially on the left side I thought it's about the Rockwell hardness test, but the conclusion sentence put everything together about the harder, stronger, resistant to impact. So I'm not sure. Is it meant to be, because right now it's as if the two objective is separated for the hardness and for the toughness for the impact. Clarify that. Other than that, okay, so that's it. Okay, so you have multiple sources. So among the gaps, just to reiterate, please verify the objective, the reasoning behind the procedure, and whether the procedure is all correct, and yeah, about the data, because there's a initial and final, if I'm not mistaken. So do verify that whether it should tally with the the procedure, or the procedure should be revisited to tally with that. Right, so that is group number 4. We will go for group number 5. Alright, so we are going for group number 5. So a video is given, link, so we'll go there. Okay, interesting. This is the first group that have video that is much less than 4 minutes allocated. This is only 2 minutes. So I assume there's no one talking, it's just word after another. So let's see. Wait. You have the group number. Okay, there's group 5 here. Okay, you separate the two information to different portion of time. That's confusing. Okay, group 5, and then okay. Okay, so to study how treatment affect the mechanical properties, to study the effect of heat treatment on microstructure. Okay, you stated two objectives. One is to study on the mechanical properties effect. The second one on the microstructure. We'll see. Okay, so I assume this portion is to address the portion where I ask why is certain procedure needed. I assume you guys misunderstand what that mean, because when you say quenching is a rapid way, this is more of description or definition of those processes. What was requested was, when we say procedure, meaning procedure of the experiment. Of course, part of the experiment you do quenching, you do annealing, you do normalizing. But why do you do that? Yeah, why do you do that? Not in the sense that, oh, to bring the temperature down. That is basically the definition of the process. Why do you want to bring the temperature down quickly? Quenching, i.e. quenching, right? Why do you do that? Not oh, I do quenching to rapidly cool, to make the hardness or something, right? It's actually to test something. It relates back to the objective. So make sure you revisited on that part, on why do you need to do the three, when you mention here three different heat treatment, right? Why do you need three and not just do one of those? So that is the understanding of the question that is requested, basically, right? To understand why do we do certain procedure. Okay, so there's only one source, is it? One source from YouTube. So again, I mentioned for the previous some of the earlier groups, because in the last submission that you have to do individually, everyone who have to find at least two sources, at least two. So when you go back in the group, you have 3 or 4, so at least multiple sources available to you, right? So why suddenly you just only use one? Is it because of the duration or what? But that must be addressed in the final report, right? One source is not enough basically for that final report, right? Unless you want to filter down what is the reasoning, etc. You have to clarify that. So this is the reading on the specimen. So they take before heat treatment. Okay, I'm reading here. There's quenching medium, and then Rockwell hardness test before heat treatment process. So if I understand correctly, this all 1 2 3 4 5 times at different location perhaps, and then take a bridge. This is before heat treatment. Okay, this is after heat treatment. So basically they test on the same specimen before and after heat treatment, right? So meaning that they label it A1, A2, A3, so that, because here the average hardness is different between the 3 specimen. Wait, what? Okay, that's too quick. So basically it's either going up or going down, is it? I cannot see. But the interesting part here is actually the initial is different, because the first one, the initial is higher, and then it goes down, but the next two, the initial is lower. But anyway, okay, how do you get that conclusion? Yeah, please verify how do you get that conclusion, because here it's the way you describe it is not about before and after. It's just the result is higher or lower, because if you see in the result, where's the result? Oops. Okay, if you see the result, let's see. I'm not sure about the first and the third, for example, right? The first and the third. It seems that the after this shaded one, this first is what is it? I cannot see. Normal, is it? My eyesight is too bad. It's too small. And then this one, oil and water. So natural air, is it, if I'm not mistaken? Okay, so the shaded one is higher on this left side compared to the right side, which is quenched in water, right? So it's like that. But the first one actually dropped from the initial one. The second one actually increases. So how do you make the conclusion then? Just compare the after result, because the way you describe it is like the faster the cooling rate, if I remember correctly, the more hardness. So which one is faster the cooling rate? I assume water compared to natural air, if this is natural air. So the way you describe it, as if the water should be higher, right? So make sure you word all these things properly, like this. The faster the cooling process, the higher the hardness of the steel. What does that mean? Because if we just say the steel hardness is higher, then lower. So going back to the results, the left side is higher, right? But if you are saying it increase, I don't know, so increases the hardness, or you, how to say, because if the starting point is all the same, then it's easy to see, meaning the final result is conclusive enough. But from the result there that you obtain, the initial hardness is not the same already. Okay. First conclusion: heat treatment change the microstructure of steel. How on earth do you get that conclusion? How on earth? Because is there anything that you have analyzed in terms of the microstructure? Right, so that is one significant thing that I noticed about this one. Your objective says something about microstructure, the procedure doesn't, the data and analysis doesn't, and then suddenly you conclude, heat treatment changed the microstructure. How do you know? How do you know, right? So you cannot have conclusion like this when I'm not sure based on what, right? So that's the thing that you have to understand what it means by the purpose of doing experiment, the procedure that we develop in order to achieve the objective, and the type of conclusion that we come up after we analyze the data. Now it cannot be suddenly, Alhamdulillah, this and this and this, when the data is not even related, right? So those are the issues that I see here. Alright, so I believe that is the end. Okay, I think in terms of the time usage, when you don't need to talk like any other groups, it takes much less time, I guess, right? However, significant things is about what I have mentioned, in the sense of you know, there are, okay, the objective, you say microstructure, right? But no microstructure data or analysis, but suddenly have conclusion on microstructure. Okay, so all this, I'm taking notes because I have to grade all of your submission. So all of these notes basically affect the grades, basically, right? The marks. But of course, as I mentioned early on, one of the objectives of this practice is to get the feedback so that you can improve in your report writing. If there's no feedback, then I assume you'll be exactly like this, and your report mark will be terrible. So please understand all these comments and rectify what need to be rectified. Go back to the data, etc., to make sure you understand what's going on. Is it correlates between procedure, objective procedure, analysis, data analysis, and conclusion, right? Okay, so that is group number 5. We will go to group number 6. Okay, so this is for group number 6. Okay, they give file. There's no link, so they give file, so we can we go to the file directly? Okay, so this is in Google Doc, I think. So alright, let's play. Okay, so in term of the, okay, I have to see what is the notes here. So in term of the time, it's 3 minutes, so it's good. It's less than 4 minutes given. This is okay. What is the group number? Because I specify, other than the member detail, the group number should be there. But this is, of course, the file name is having group number 6, but in the slide itself, that is missing, right?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Amirul Ashraf, and I will continue the presentation about heat treatment experiment. So this is our table of contents. It is divided into 4 components, which is objective, procedure, data analysis, and conclusion. Our objective for this experiment is to analyze the effect of heat treatment, annealing, hardening, and tempering on the mechanical properties of selected specimen. The second one is to know the different cooling rate between different quenches, which is water, air, and furnace. And the last one is to study the hardness and toughness testing and its limit.
Okay, I assume you are reading from your text. But the arrangement doesn't tell you is what is displayed here, right? I think number 2 and number 3 is switched, so that's number 1. But that's more on presentation issues, right? Now, in terms of the objective itself, so you state here, okay, you list the objective, good. But okay, to analyze the effect of heat treatment, on mechanical properties, okay, to study hardness, its limit. What does that mean? To study the hardness and toughness testing and its limit. What does it mean? To study, what limit are you talking about? To study hardness, we want to study what the meaning of hardness and toughness testing. I assume to study hardness testing and toughness testing and its limit. Okay, make sure that you clarify that. I'm not sure what I mean, but I hope, because you have written here something about this testing and its limit, you have to conclude something about something limit. Otherwise, then there's an issue with the objective. Number 3, to know the difference cooling rate. Okay, so this is interesting objective. I will seek for the conclusion for this, because you say you want to know different cooling rate between, so meaning that I will seek in the conclusion what is the different cooling rate. I'm seeking for the rate, right? Degree Celsius per hour, per minute, per second, or whatever. If that is not existent, then your objective has a problem, or the whole of your study is a problem, because you do not seek to achieve the objective, right? So either or. So make sure you take note of this, and decide what you need to revise, unless actually you cover this. I'm very interested, because no one actually calculates so far the cooling rate.
So in our procedure, the first procedure is the specimen are cooled into water, air, and furnace after heated. So what it means by cool in furnace is when we let it be in the when we let it the when we let the specimen cool in the furnace. So the second one is the Rockwell hardness test is taken after the heat treatment process and recorded. And the last one is the toughness was measured using choppy test with different height until it break. What it means by choppy test, where we use a pendulum in specific height and let it hit the specimen until it breaks. So that's all from me. Thank you.
Okay. Several things. One is that, as I mentioned early on at the beginning of the video, is that what is requested is why certain procedure is needed. Reason why we do certain procedure. I'm not sure whether it's coming, but it's not here. But I'm just comment on the procedure first. When you say specimen are cooled and then into water air furnace after heated in the furnace, it makes sense if you say it's cool. But the word cooled, there's a problem there because it implies certain things. Um, and cooled in furnace. What do you mean by that? Because it's not really cooled in furnace. It's just left to cool down slowly, right? Meaning that as the furnace temperature slowly goes down when you switch off, we just leave it as such. It's not really cooled. It's just let it cool down, right? I know English is not our main primary language, but it should at least make sense in that sense. Okay. To number 2, the Rockwell hardness test is taken. What does that mean? The Rockwell hardness test is taken. Are you taking, or are you imply? Do you want to say that the value of the hardness of the specimen is taken from after you have done the Rockwell hardness test, or something? So again, this is language perhaps, but yeah, because we are communicating using the English language, so at least it has to make some sense. The toughness was measured using. Okay, what does it mean? The toughness was measured. Okay, fine. Using chopper test. Okay, with different height until it break. What does that mean? Do you mean that, okay, this height will not break yet, this height not break yet, this height not break yet until it breaks? Is that what you mean, or what? So because there's a big question there. What that mean? If you mean like that, meaning you repeatedly apply force from different height until it breaks, I want to know why. What is the justification of that? Right? I'm really interested to know why you do it like that, because I have never seen anyone do it like that.
You.
So for analysis part, as you can see, this is the result for all the heat treatment that had been done. Tensile strength, yield strength, and hardness.
Okay, are you interested to show those to me or not? Because it just goes through like you purposely do not want me to see because it's too fast. Okay, so you have the 5. Do you have 5 different heat treatment when you say, because that's tempered here? Do you have any tempered before? Because I didn't realize that, because when you say about, I'm not sure whether you say about something. So you just my comment, make sure you whatever you see in procedure and the result, it tallies, right? And then what should I observe here, right? So what is that? Tensile strength. Okay, nice, interesting. Tensile strength. You portray a result for tensile strength, but you didn't do anything about tensile strength, right? You didn't do tensile test. Correct? Correct me if I'm wrong. So how do we understand this? Suddenly, if you just do whatever procedure that you have just mentioned before, suddenly you get tensile strength, really? And then percentage reduction of treated and treated sample. What percentage reduction of what? What's the unit of this? 20, 40, 60, 80 percentage reduction. So percentage reduction of what? Of hardness, of toughness, of tensile strength, of what? I'm not sure. What is the purpose of this? Hardness of treated. Is it related? Because when you say reduction, then reduction from what to what, so there must be, I think, initial to final. So all these things, okay, all these things, when you want to do the report, make sure when I read it, it makes sense, or when anyone read it, it makes sense. Otherwise, percentage elongation. So I'm assuming this is about tensile test, and then yield strength. So did you mention that the sources? You didn't mention source, right?
Increase with plastic deformation while ductility and impact strength decreased due to strain hardening effect. Normalization treatment had also resulted in higher tensile strength and hardness than annealed samples. This treatment is recommended as final treatment after manufacturing. The tempered sample gave an
Okay, all of this, even though I do not primarily judge you on presentation aspect, but you have to consider those things, at least as a courtesy, to at least, not to say pretend, but at least try to make the audience understand what's going on. If you have the graph, and then it's still understandable in a report form, so that, oh, okay, wait, let me see the graph. But in a slide, you have, okay, just take a mental picture of the graph, and then I will explain later without you able to see the graph anymore, and just memorize what is the graph like, and just try to connect the dots. What yeah, so what I'm trying to say is, when you present, hopefully you have the intention to make people understand. I know some people present with the purpose not to make other people understand. Make sure they are so confused as ever, so that we can escape with not knowing anything. I'm not sure if anyone have that kind of intention, but I cannot follow like this, right? Yeah, this relate to what? And because so okay, so take note of this in the report. Make sure, okay, I give you instructions specifically. Hopefully at least group 6 have to listen to this, because I do not make it compulsory for each group to watch for each group presentation, because it will be long. This video will be like how many hours, right? So at least you will be listening to this, group 6, right? I want to see in your report, the graph is not separated from the discussion. Never do like graph and then certainly discussion in a different page. It have to be side by side or on top or whatever, right? Meaning that when I read the paragraph, I can see exactly that graph is there, and I can see what is going on. Oh, this is talking about this one, right? So make sure you understand that. Do it like that, especially group number 6, because this comment is made specifically for group number 6. Maybe I'll make, hopefully I remember to make at the end a general remark, so that every group do the analysis like this. Because I really hate when people do, oh, result, there's a plot, and then discussion is somewhere else, that I have to flip 3 pages to see what are you talking about, right? So it's like you purposely want to torture the reader, right? So but you feel free to do so, because I will torture you back with your marks, right? So, but I do not want to do that.
From the results obtained, it can be said that mechanical properties depends largely upon the various forms of heat treatment operations and cooling rate. Thank you.
Okay, so again, go back to your objective. You say you want to know different cooling rate, because that's how you phrase it, right? Normally, that's a, if you still keep that kind of word in your objective, that's a suicide, because you never measure the cooling rate in this kind of process, right? So you will not know what is the cooling rate. You can say that we know for sure that quenching is cool, the cooling rate is much higher than other processes, and we want to see what is the effect of different, significantly different cooling rate. That makes sense to some reason, because we know for sure the comparison between the two. But you do not know exactly what is the cooling rate, and you do not measure the temperature or something. Alright, so that's group number 6. Hopefully you take notes. There's major things here, in the sense that the results and the procedure and the objective is all disconnected. Please do. Okay, until the end I think you do not put the sources, so that's also, unless I missed something, but I think I've watched throughout, you do not specify your source. I'm not sure whether that's from one source or many source, or I do not know. So significant issues there in the presentation. Hopefully you rectify that in the report. Alright, so that's for group 6. We'll go for group 7. Okay, now so we are going for group number 7. So we go to the presentation. So the video is less than
Assalamualaikum. We are
4
from Group
minutes.
7.
For the objectives, the first one is to study the effect of different heat treatment on material properties of 4140 steel. The second one is to analyze the stress-strain graph for different heat treatment.
Okay, wait a minute. So the objective, it state about to analyze the stress strain graph. Of different heat treatment. Interesting. This is the first one that specify the objective to actually analyze stress strain graph, right? Meaning that you will not be doing, sorry, you will not be doing about hardness here and impact as well, right? Because stress strain graph is something else. Let's move forward and see what is going on.
The procedure. The first procedure is to heat two samples in oven to 1600 Fahrenheit. For one sample, we just turned off the oven and left it in to cool down. It is called annealing. Next, another one sample, we just take it and immediately quench in oil. After that, we perform the harness test, and then we heat it to 1000 Fahrenheit for 1 hour. It is called tempering. And then we just leave it to room temperature to cool down. So, for both of the sample, we need to perform the Rockwell hardness test. After we get all the data, we put it in the table and plot the graph so that we can achieve the objective that we want.
So next we go.
Okay, I'm trying to understand. You have two sample. You put in oven. For one sample, I hope, because it's not clear, right? But I understand it, after you heat for whatever the time is not specified, you turn off the oven and let it cool down. So that one sample. For another sample, you take and quench in oil, and then you perform hardness test. To which one I'm not sure. I assume for both. After both cool down, you perform hardness test, and then you heat back both, or which one? because suddenly you hit, so you hit back, is it, for 1 hour and then return, and for both perform rock harness. So something is very unclear about this process. I'm not sure, but to me it's very unclear because you have to sample. I assume you say number 2, after the heating is finished, you turn off and one just leave one, and then another one, you number 3, you take out and quench. Then you do test on both, I think, and then you heat them back again, and then you cool it back, and then you perform because on number 4 you say perform hardness test, and number 7 you say perform Rockwell hardness test. So is number 4 hardness test different than number 7 Rockwell hardness test? Please clarify because I'm lost. That's number 1. Number 2, going back to the instruction given, what is needed is why certain procedure, certain base core procedure is being done. That is not addressed here. Please address when you do the final report.
Go to the citation of resource. So in this video, we use the data that we got from the internet. The link is given at the slide. So as we can see at the front page of the lab report, this data is made by 2 people, which is the first name is Justin Lins and second name is Troy Topping, on years 2011. So next we go to the...
So you just use one source. Can you clarify why? Because you should have multiple sources, right? So if you still, I'm not sure whether it's just for this video you select one, or in your report you will also only select one. If you only select one, you have to specify why, what happened to the others, etc.
result. Our first result is the metal with no heating treatment. So as we can see, the hardness of the no heating treatment is 98.2 and 96.5. So next we go to the first method, which is annealing. As we can see, after the metal undergo annealing, the hardness is 81.8 for the first try, and the second try is 79.1. So in unit RHB.
Okay, from your procedure, you only take hardness test. So what about the rest? What about the elastic modulus value, yield strength, ultimate tensile strength, percentage elongation, percentage reduction, and area? Do you measure those? If you do not measure those, how did you suddenly get all this data? Or how to understand this? That's number 1. Because the confusing thing is that in your objective, you specify to analyze stress strain graph, but in your procedure, so you do not mention anything about hardness, but in your procedure is only about hardness, and the result suddenly you have tensile test as well as hardness. It is confusing.
So for the elongation, first try is 26.15% and second try is 27%, which is quite higher, and we can say that the process annealing will make the metal to become more ductile.
Next, we proceed with quench and tempering experiment. In this experiment, they have done also 2 trials, which A and B. And here, as you can see in this table, is the result of the test they done onto the specimen, and they overcome with the hardness, which is stated here. Next, we proceed to the graph of annealing. In this graph, you can see that the stress that they put onto the specimen is about 54,000 psi. Compared to the quenching and tempering graph, they receive about 180,000 psi, which is much larger compared to the annealing. And for the conclusion, we can see that the quenching and tempering makes the specimen harder compared to the as received specimen, which you can see here the number is a lot bigger compared to the S receive. And for annealing, it is a little bit softer compared to the S receive. Thus, we can say that annealing makes the specimen softer.
Okay. So please do check what exactly you're focusing on, because the objective is on one thing. I assume your objective, you try to tally with the final conclusion, but in the middle, the procedure, it's totally not related, and then the data is mixed between some about hardness but some about tensile, but the procedure doesn't have any tensile, uh, and then yeah. hmm. It's very hard to comment when it's disjointed like that, right? Because on which one should I comment, on the objective or on the procedure? On Because it's from like two different unrelated studies, unless something is missing or I cannot see pass through certain things. I'm not sure, but please rethink for your report, so that make sure that it is maybe, meaning anyone read the report can understand from the beginning until the end. It's like connected and related information. All right, so that's for your group number 7. So we'll go to group number 8 next. All right, so we are going for group number 8. So the submission is uploaded on YouTube. So 3 minutes left, at less than 4. All right. Okay, group information is there. All right.
The objective of this experiment is to investigate how different heat treatments affect the mechanical properties, which is toughness and hardness of different materials.
For the procedure of the heat treatment experiment, first pick 5 mild steel specimens and put 4 of them into the furnace at 900 degrees Celsius for 1 hour. The last one will be the control specimen. Second, do different heat treatment to the 4th specimen, which is normalizing, quenching in oil and water at room temperature, and annealing. Third, using Brinell hardness machine to test the hardness of the specimen. Fourth, using pendulum impact tester machine to do a choppy impact test in order to find the toughness of the specimen. The last one, repeat step 1 to 4 by replace the specimen to aluminium to make a comparison with other material.
Okay, now we move to the
Okay, so in terms of reasoning of the procedure, I think that's a good overview of the procedure. But in terms of why we do certain things, why those procedure is as such, from my observation, it is not being covered, right?
our data of the experiment. According to the Haneko, Kamal and Ogujiri in 2012 in their Journal of Effect of Heat Treatments on the Properties of My Steel using different quenchants, it clearly indicates that there are the variation in terms of the value of hardness and toughness for each type of heat treatment. By comparing the value of toughness and hardness of the my steel between the specimen with no heat treatment and specimen with heat treatments, we can see that the specimen which has been quenched by the water give the higher value of toughness and hardness compared to the our control specimen. Meanwhile, the other specimen that undergoing other heat treatment give much lower value of toughness and hardness compared to the specimen with no heat treatment, which is the our control specimen.
Now let's see the data that we got for aluminium. Based on the aluminium table, if you compare control specimen hardness with other heat treatment specimen, we can see that hardness value of specimen that has been quenched by water and oil, annealed and normalized will drop. Meanwhile, the toughness value will increase compared to control specimen. Okay, that's all the data that we got for aluminium. The data that we got is from the link that are already given on the below of this slide. which is written by 3 person, which is Nurul Hilmi Zaidah Nasir, Muhammad Ahadlin Muhammad Daud and Muhammad Zulkifli Selamat at November 2014. The topic is the effect of heat treatment on fatigue and mechanical properties of C0C1 aluminium alloy.
In conclusion,
Okay, so I didn't catch because I think there's two source or one source, because I noted at the beginning there's only one source because you didn't specify the sources given. You just attached down there, right? So there's two different source. Okay. Okay, but of course in the report I assume there will be more. There should be more based on the previous task, but if you disregard certain things, why? In terms of the trying to make sense of the data, going towards the conclusion, I think it's fairly well done, in the sense that okay, comparing this and this and this. However, because it's purely verbal, meaning I have to keep track where this one quenching water where. So in presentation approach, it's quite poor, but in terms of the attempt of making sense of the comparison, etc., it's there, right? So make sure to improve that in your report, in terms of, because when we want to say higher or lower, etc., in terms of graphical, it's easier to understand. Oh, okay, right? Otherwise, you have to spell out, oh, for this one which is 90 blah 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 compared to this, yeah. Okay, so in terms of the analysis, then okay, so
different heat treatment applied will affect the hardness and the toughness of materials. Besides, different materials also can cause the different hardness and toughness of materials.
okay. Wait. The last conclusion, even though we can expect it to be true, right? Different material also, have different hardness or toughness, but I don't think that's really being a part of the discussion that was discussed before, right? Because you just compare within one material, what is the effect of different heat treatment. If you want to also conclude what is the effect of different material, you have to put side by side different material with same heat treatment, for example, right? So make sure you put all of those together, so that you can conclude things like this. Otherwise, even though maybe you can, on your own you look, yeah, it's different, but from how to say, analysis point of view, you have to have that flow, right? Where, okay, comparing this and this and this, that's where we can see this and this and this, and that's why we conclude this and this and this. You cannot say have total silent here, not comparing anything, and then suddenly you conclude. How do you conclude that, right? Other than that, I think it is quite decent attempt of analysis on the available data. Okay, so we go to group number 9. Oops. Okay, so this is group number 9. So let's see the video. Okay, so it's 5 minutes. It's almost 6 minutes. Wow. So this is 1 minute 52 second more than 4 minutes allocated. Wow, that's okay. Wait. Is there any group number? No group number. Group number missing. Even though, okay, in the title also is missing, right?
Assalamualaikum warahmatullahi wabarakatuh. For the experiment of heat treatment, our objective is to investigate the conventional heat treatment processes and to study the effect on microstructure and mechanical properties of steel after heat treatment, and to calculate the hardenability and toughness of steel.
Okay, you mentioned several things. One is to investigate conventional heat treatment process. Okay, that's one claim that is interesting. That's your objective, to investigate the conventional heat treatment process. So I will be looking towards your finding because you want to investigate the process itself, and then to study effect of microstructure. So you want to study microstructure. Okay. To calculate hardenability. Interesting. Calculate hardenability and toughness. So you mentioned 3 interesting objectives. Normally you will be evaluated based on the stated objective. So yeah, interesting to see.
Is the finding according to Justice Lands 2011 and using 4140 steel, and this is the nil. And
well, it's still with the findings, so you do not have anything to say about the procedure. But the video is still long, right? So is there any issue about the arrangement?
Quench template. And according to this table, the ultimate tensile strength of anneal steel is much higher than the quench and tempered. And other than that, the properties are almost the same. As the modulus, yield strength, hardness is almost the same, but maybe hardness for anneal is much higher than the quench tempered. And this is the finding according to Ismail Khatif, Kachik and Shahudin 2016, and using carbon steel. And according to this table, it shows that the hardness of carbon steel is much higher when using water than air, and after tempering, even when using the tempering, the hardness of steel is much higher when using water and using air. This might be because of the rapid cooling create the microstructure of martensite that are much stronger in hardness than the other types of microstructures. And this is the finding of hardness with increasing temperature. As you can see here, when the temperature increase, the hardness for both, whether it is water or air, decreasing. And this is the theory. Heat treatment is the combination of heating and cooling applied to metal or alloy in solid state, and produce microstructure and design and properties that we want. And for example, perlite is formed from around 350 to 300 to 650 degrees C, and among them are the coarse perlite, fine perlite, and bainite. And austenite will transform to martensite if it is quenched rapidly. And ferrite formed by slow cooling of austenite.
Assalamualaikum warahmatullahi wabarakatuh. So for the analysis part, in the experiment we use 2 types of conventional heat treatment, which is annealing and quenching tempering.
Wait, so I'm trying to understand the flow, because what just happened is also the analysis, right? Meaning a data from different sources and that is being analyzed, right? And then this is analysis as well. Okay, let's go through first.
So from the table that we found that the ultimate tensile strength goes for the annealed 4140 steel compared to the quenching and tempering due to the heat treatment processes, and the result that we found in the annealed steel that it shows it can withstand high level of stresses, and also it can have a high resistance or corrosion value, and therefore we go for the tempering and annealing. Tempering, the higher the temperature is, the lower the hardness and the higher the toughness, and as we all know, higher toughness means higher ductility, and lower toughness means lower ductility, and higher hardness is goes for the brittleness. And for the discussion, according to the article that we read from 2011, that annealing, it has always to do with grain structures and reduce the hardness and also the brittleness. And for the other part, which is quenching, it also got a lot of things to do with the formation of martensite through the rapid cooling of the steel. And this modulus of elastic is the same for specimens, and happen because the heat treatment only affects the microstructure instead of the bonding structure of the atoms, and when the microstructure is being affected, that means it also got to do with the hardness, toughness and strength of the material. And the other discussion from the other article, according to the Ismaili Khatib 2016, that also the temperature also it helps in terms of microstructure and the austenite and macrosite. The higher the temperature is the rapid cooling of microstructure and also the level of austenite and martensite, and all of this has to do with the hardness and toughness of the material. And as we can see here from our own discussions and analogies, that the higher the carbon content, the higher the hardness, and that is the reason that the mild steel shows a good hardness value. And as we said before, the tempering also is related proportional to the hardness and toughness. And this is basically what we can conclude from heat treatment processes, and the experiment shows a major difference.
Okay, so about the analysis, right, and how to formulate the conclusion. My comment is that it is all over the place, because I'm not sure whether there's a correlation, because there's no specific procedure that is being specified, right? You strictly go to some of the results found and some of the discussion found. Some interesting points you noted from discussion elsewhere from the sources, right? The thing that maybe is a challenge, I know, several things. One is to work in groups in these circumstances, so the collaboration may be a bit off in this particular groups, that the combination doesn't seem meshing together well together. Second is how to pick what is relevant from all the sources to become one, what is the word, congruent, one. Basically, you specify what you want to analyze, the objective, and then what exactly the procedure involved, and then what is the data, because you there are many things that you can get in terms of tensile properties, etc. All of those sometimes come from different sets of or type of experiment, right? Tensile, hardness, toughness, all those impact, all those are different set experiment that you do, right? It's good if you want to combine everything, but the procedure becomes involving everything. That should be clear. But then when you specify in the objective, you want to, okay, because in your objective there's some problematic statement, like you want to investigate the conventional heat treatment processes, for example. So you want to investigate process itself. There's a meaning behind that statement that I don't think this level is ready to address. So that's not one thing. Then you want to study microstructure. If you really want to study microstructure, you have to zoom in to look into the microstructure, right? using microscope, optical microscope, or SEM or whatever, to see the grain or whatever, right? But it's not here, so you shouldn't, if you do not want to study that, it shouldn't appear in the objective. Alright, and you say calculate hardenability. I'm not sure whether there's any calculation being presented, because you only show data comparison, etc. Yeah, so in terms of the conclusion,
when it comes to the three type of heat treatment processes: annealing and quenching and tempering. And also we can conclude and we can assure that the highest level of quenching, which is water, that can give us the highest value of hardness. And thank you so much for listening and watching, and I hope you benefited from our presentation, and these are the sources that we cited from. And yeah, that's all from us. Thank you so much.
okay, so there's 4 sources, but in terms of what I requested, okay, but we'll just, yeah, because the way that I give the task, because I actually give a specific flow. So this is at the end, right? This is like, because in terms of the flow that I give, in terms of the instruction, I just say mention the site used first, and then, because it's not in the format of a report, where it's basically like a citation, right? It's more on, okay, this is the resources, and then from there, this is the synthesized data, right? I expect it to be like that, but anyway, you cite your sources, but anyway, so make sure you understand, this goes in life, right? Make sure you understand what is the given instruction, so that you understand exactly what is requested, and you fulfill what is requested. Avoid assume based on what you previously know, because it might be different what is being requested now, right? So hopefully take note of that. Hopefully take note of all the comments. Alright, so that's the end of group 9. I didn't expect it to be this long. We only have covered only the first experiment. We have to have another set from group 1 until group 9 for the second experiment. Wow, it will take a lot of my time to go through all of this, but because of that, I think I will separate it into 2 different video for my feedback. This will be the first one for the effect of different heat treatment, right? So we will go into the second one. After this, I process this first, I think, so that at least you can get the feedback on one first, even though the second one will be a bit delayed, because it's taking a lot of time, a lot more than I anticipated. Actually, this is already 12:22 a.m. and I only finished halfway in term of the task, if you consider that I have to go back from 1 to 9 for the second experiment. This is not included, because this is just recording and give feedback, not yet processing the video, upload, etc. And then I have to have another cycle. Hopefully I can sleep tonight, because I want to rush, because I do not want you to have the excuse that they say the feedback comes too late for your submission. Alright, so we'll end here. I'll make another video inshallah for the second experiment. Wallahu alam. Assalamualaikum warahmatullahi wabarakatuh.